apologies for anybody who thinks they've seen this talk before, because I did do one on geology used several years ago for Natural History Society. It started off as something instigated by Brenda when she was teaching geography. One of the parts of the course for geography was changing places, and one of their case study areas was the Lower Ouseburn, and she kindly offered me up to do a presentation to her students on the geology of Ouseburn. So I'm fine, okay. Lower Ouseburn, this one. So we went along, had a look around, and discovered there was next to nothing in the way of the rocks there. So, but did it anyway. And then the Ouseburn Trust had me giving a talk in the pub for them, and an evening walk, and then the Gosforth Church had me doing something on South Gosforth, which included the Ouseburn in there. So I expanded it a little bit. And last summer, Jesmond seniors wanted me to do a talk on the Ouseburn as well. So I extended it to include all the Ouseburn. So it's changed a little bit. So a few other little aspects in there. So hopefully you'll all get something out of this. Apologies for anything that's a bit grainy. This is the worst slide. And not used to presenting them on such a large scale, so I've been rejigging a whole bunch of slides to make sure that they're hopefully nice and sharp. But that's where the Ouseburn is. So we do an awful lot of talks at HSN on the Ouseburn, and particularly the Ouseburn Way. This ain't the Ouseburn Way. The Ouseburn Way bits go, where's my cursor? Anyway, the Ouseburn Way it takes off at the sort of corner. You can see the grey splodge in the top. That's the pond at the nature reserve. And the Ouseburn Way basically just covers that northern stretch. But the Ouseburn itself starts off way off to the west. Okay. So that's the area I'm going to sort of cover from there right the way to the confluence of the Tyne. So the geology, the Ouseburn, this is the first geological map of the area by what we now call the British Geological Survey. 1870 solid. Solid basically means this is the bedrock. If you took everything away off the surface, all the soil and everything, this is what you'd see. And this is the Newcastle map, which is showing in Gateshead. And the Ouseburn is, look, the Ouseburn's in the top right hand corner. And the colouring on here, mostly just grey, all coal measures. Okay. All the white lines on here, they're all faults, structural faults, fractures in the surface. Moving on, there's not a lot of details to be gleaned from this one. The most recent map is the 1989 solid, outlines the Ouseburn stretch in the top corner there. I'll describe some of the colours. I'll zoom in a bit on that. The greens are sandstones, the greys are shales or mudstones. The black dashed lines are coal seams. Black dashed lines with little tick marks on them. You can see one in the top right hand corner. So this top right hand bit here, you can see there's a dashed line with little what we call tick marks on it. These little lines at right angles. That's the marking the position of the fault. All these dashed black lines are the coal seams, and some of them have got the names on. High Main for the High Main coal seam. Other features that we've got, this area where we've got lots of sort of hashed areas, these diagonal lines running across the area, that's what we call made ground. So that's all spoil heaps and rubble and everything that's on the surface. And the Ouseburn, you can hardly pick it out on this lower part, but appears here and then winds off on the top part. So this is just the lower Ouseburn section here. Another thing you can see on here is a line coming down here and disappearing off at an angle there. That's a line of section on the maps, they'll actually produce a vertical section along that line so you can see what's going on below ground to sort of help put you in a picture of what's actually happening in the area. And the area around Ouseburn is covered by this part of the vertical section here. Again, the green are the sandstones, the grey are the shales, the black lines are the coals, and then there's a little line in here with an end in, which is what's called a marine band. This is a particular band in the sequence that has marine shells in it. And those are very important in geology for correlating one area of the coal fields to another area somewhere else in the country. The fauna that you find in that marine band is specific to that band. The next ones up have a different fauna. So if you find that same group of organisms in the marine band, you know you're at the same level in Nottinghamshire that you are up here. That was very important when we were searching out for coal seams that produce that to relate between them. So that's how the sections work. Working from the deepest, the oldest, down the bottom up to the youngest at the top. This is just showing you that vertical section along that line. And conveniently the section goes through Jesmond Dean, so you've got Jesmond Dean here. All the greys are the coal measures. Coal seams, the major coal seams are marked on here in the dashed lines. Marine bands are marked on as well. And this bottom MG, that's the millstone grit, which we don't really have up here, but we'll talk about that else another day. And what you can see on here is that these are all sedimentary rocks. Okay, so they're laid down horizontally bedded, but they're not horizontal now. Subsequent plate movements have tilted these things, and they're generally tilting from northwest to southeast, just gently, and that makes an important factor for what we see in the Ouseburn either side of the river, because we get different rocks on one side to the other because of this tilt. Okay, just an aerial view. This is Callerton to the west of Newcastle, and this is where the Ouseburn starts. Okay, out here, and then it winds its way off through here, and off past through Callerton, and then around through to Gosford Park area, basically past the golf course, and then it swings around and then travels southwards till it joins the Tyne. Most of this is very low lying. Nothing really to see in the streams here at all. And this is what it looks like in that source area, just a boggy wetland area. And as you go downstream from there, you come to Callerton Ponds, a place I discovered during the COVID. I had to do walks for health. Discovered these. Quite often some birds on there, and it's just a tiny little trickle used at this point, nothing really much going on. The only interesting geology there was to protect these banks in places to stop them eroding. There were big blocks of sharp granite just standing around. This is the next map up from the Newcastle map. This is the Morpeth sheet, and the upper part of the Ouseburn is actually on the Morpeth sheet. I put some stars on to show you where the source of the Ouseburn is. This is about its northernmost limit, and then it swings down to head down to South Gosford around here. And you can see it only travels through these grey and green areas. It's not in any of this area, which is the lower coal measures and the limestone groups. So it's all over these sort of middle coal measures strata. The other type of map I have is what we call a drift map, and this has all the soil and everything, all the glacial deposits and boulder clay superimposed on all the solid rock. If there's none of the boulder clay there, you'll get outcrops of the bedrock showing. And that's again the same position of the path of the Ouseburn as it's working its way through. The nature reserves appear somewhere. Most of the pale blue is boulder clay, so it's pretty much all boulder clay. There's a little bit of alluvium in clays and things in there as well, and some sands and gravels. The other thing, one of the other features we've got in the Ouseburn is another structural feature. We were talking about faults before, and this is South Gosforth area, Long Benton area, Nunsmoor, Newcastle, Ouseburn coming along around here, and this dashed line running up here with little tick marks on it disappears off here. This is some of the upper coal measures, a few tiny little areas we have of the upper coal measures. This area down here, that's the 90 fathom fault. It says on the 90 fathom fault. 90 fathom fault is a major structural feature in the north of England. It stretches from often the North Sea near Cullercoats, all the way through past Hexham, right the way through to Maryport and into the Irish Sea. And it connects at depth to the Iapetus suture, which is the join between Scotland and England, effectively, when Laurentia and Gondwana collided, or Laurentia and Apollonia collided. And so it runs right the way across the country. You can see it at Cullercoats, top end of Tynemouth Long Sands, right to the very top. The headland district sand is yellow Caribbean desert sandstones. The stuff on your left, you can see coal seams in it, is carboniferous coal measures. And it's 90 fathoms because in a particular point in some of the coal mines, we measured the difference between the strata on one side and the strata on the other side, and it was 90 fathoms different. Not the same all the way across the country, but a huge fault there, huge movement, which created problems for the coal miners. All these faults, you can see, lots of areas of Britain don't have anything like the detail that these maps have. If you go to the Tudors, far less detail, because there were no resources for them to do mining. But all mine records help contribute to putting all these faults in place, so we know what's going on underground, largely due to the miners. Again, this is that sort of same section area. On that north sheet, there's the upper coal measures and the middle coal measures running through. Lots of shale. There is more shale than anything else. Big sandstones. The sandstones are really important, used as building stones and millstones and things like that. Most of Newcastle built out of wonderful golden carboniferous sandstones. And again, you can see the same feature on here, the dipping of the strata along this section. Here you can see there's a big change in the level. This, the boundary between the lower coal measures, the grey, light grey, and the dark grey of the upper coal measures, has a big jump here. That's the 90 fathom fault. So I'm showing you how much displacement there is. So this is the south side of it, and this is the north side. Okay, so where are we talking time-wise? Carboniferous, we are 315 million years ago, around about here. But the story goes back really a lot further than that, back to the end of the Cambrian. And try and show you through there. This is a reconstruction of the continents on the Earth 470 million years ago. We're looking at the South Pole. The equator is marked up here. This is a continent called Laurentia. That's where Scotland is, that little yellow star. This is Apollonia, and this is Gondwana down here. And that's where Newcastle is. Okay? It is, the Scorsese, the guy who does these things, you actually put in the place name, and it puts the star, then you put the place name in, and then you can follow it through time. It's really good. You flip it around and rotate it, you can have clouds on it if you want, all sorts. Absolutely brilliant. Doing all these reconstructions. So what we're looking at here, this is early Ordovician, so we're already actually, this ocean opened up in the Cambrian, and it's already starting to close. So this is Laurentia up here, south of the equator. We're much nearer the South Pole. Time goes by, skipped 430 million years ago, the mid-Silurian. And you can see this area hasn't moved much further north, but England has. Apollonia has. It's closed the ocean up an awful lot, and that happens by what we call subduction. So one plate, oceanic plate, goes down underneath the other one and creates mountain building vents. And what we get here is this huge mountain range starting to develop up here. Caledonian Mountains. Note that Greenland and everything's much closer to Scotland. Scandinavia and England, moving closer to it. So that's closing that up in the mid-Silurian. Skip to the late Devonian, and we're together now. About 414 million years ago, England and Scotland joined. And this huge mountain range here, Scandinavia here, a little bit of a valley in between, and this marine basin sort of down here, this closing ocean here, Gondwana's catching up now and closing this other ocean. So the Iapetus Ocean, Iapetus was the father of Atlantis, so Atlantic Ocean, precursor, Iapetus. And this one's the Rheic Ocean. So late Devonian, closed mountain building, still south of the equator. Move on, early Carboniferous, so this is just a little bit before the age of the rocks we're looking at in Ouseburn. And this is where Newcastle is, and we're right on the edge of this basin. And these mountains, huge mountains, these mountain ranges were absolutely enormous. And then late Carboniferous, the whole lot's closed up. We've formed a supercontinent of Pangaea and Wessex in the middle of it. Okay, so that basin's disappeared, there's nowhere for water to go down. But we're north of the equator now. We were just south of the equator there, north of the equator now. So that's warm, tropical climates, a lot of rainfall. And those big mountains, we normally say they were Himalayan sort of stature, Alpine at least, but probably Himalayan. The Caledonian Mountains aren't Himalayan now. They've eroded away, and the sediment that's been produced has been washed down and into a delta, depositing the sediments in a marine basin, and gradually the delta's built out, prograded, filled up that basin, and formed a land surface. And it's on that land surface where the plants grow, the trees grow, the swamps are, that forms the coal. And we normally relate this one or compare it to the Brahmaputra and Ganges Delta in the Himalayas. So that's just a diagram of it. This is an aerial view, satellite view of the same things. The Himalayas here, Brahmaputra's coming around down through the valleys here, emptying out into the ocean here. And you can see all the finer sediment to the south here. And then this coarser material here, we've got a land surface here, lots of little branches in this river system. That's what was going on in our delta. It spread right the way across from Ireland, right the way across to Western Europe. And it produces what we call a cyclothem, a cycle of sediments. We start off with sort of distant sediments. The further away you are from the source, the gentler the flow becomes, and the fine sediment drops out. Any energy in it, it'll keep the fine sediment floating around. Heavy sediment, pebbles, boulders, things like that, they drop out earlier in the system. So you start off with heavy material high up in the river system, and then finer material as you get further and further into the ocean there. But this gradually builds out to the south, so your delta pushes out, and you gradually get coarser and coarser material as you go up the sequence. So you start off with this finer material out in the ocean, basically, and then as the delta builds out, it gets coarser and coarser, then you end up in the river channel system. These are river channels. You get a land surface, you get swampy areas, and you get coal, peat forming, which eventually will turn to coal. Then you get a change in sea level. That's the easy way of putting it. You get a change in sea level, climate change, global warming, things like that. This happens all the time. Milankovitch cycles, the change of the orbit of the Earth around the Sun, there's ice ages and warmer periods. And so that can change the sea level. We've also got active faulting. You saw all the faults on the map. You're getting extension going on, producing faulting. That deepens the basin, gives you more room for sediment to build up as well. So you get repeated cycles of these, each one topped off in an ideal world with a coal, and going back to these finer sediments above. So that's why I've got that repetition of greys and greens and greys and greens and greys and greens with the coals on the vertical sequence for the This is the upper Brahmaputra, steep valleys, lots of boulders and things up here. One main river channel coming down. This is lower down, and you can see it's already spreading out, much more gentle, meandering, graded systems, lots of flat plains with vegetation growing around. It's farms here, but it would have originally been just forested. And that's like what we would have had in the Carboniferous, lots of swampy areas. In Here, this is West Chevington, and it was operating. It's open cast coal. And you can see the size of the vehicles. Huge great area. And here we've got repeated layers of sandstone, the yellowy stuff, shales, the really dark bits will be coal seams. So we've got this sequence of materials repeating West Chevington. And the same sort of stuff's happening in the Ouseburn area. Exactly the same, just there it's open cast mining, now it's largely covered by housing. I don't really like that cyclothem thing because it keeps talking about marine shales and things like that, but where the lower coal measures were just on the edge of the delta by the coastal plains. The middle coal measures were mid-delta plain, they were away from the sea. So changing sea level has no effect on that little bit. Where we're getting a lot of our coals, most of our coals, are these peat swamps, which are formed by flooding, overbank flooding of levees on the major river systems, just like you get with the Mississippi. And you get lakes and peat swamps where all the trees grow. The sea's way off down here somewhere, so changing sea level here doesn't affect these. And in the middle coal measures, you don't really get these marine bands, which is what occurs when you've had a marine rise and therefore a marine flooding of those coal swamps. It's a relatively short period where you get these marine fossils forming. What we do get is we get what we call mussel bands. And these are forming those peat swamps. And these are freshwater mussels that form in those peat swamps. So we're nowhere away from the oceans there. Okay, so this is one particular cyclothem here, the high main cyclothem. You've got high main coal, which was the best coal. The high main and the low main were the ones that really wanted to work. They were about 6 feet thick. And they were the best coals, but there would work anything that was between those as well, any sort of reasonably sizable. So that's your coal, you've got a sandstone, and then you've got a marine band when there's been one of these marine incursions in the cycle there. And that's what we've got in this area. There's the high main post sandstones underneath the town, where the high main's around the edge of it. It's running all the way around here. Okay, so seeing West Chevington, Newcastle's not very good for looking for rocks, so there's not much around, which is a shame because if you look at what the building's being made out of, political stone. This is an older West map, and this is Chesney Dean, Castle Farm Road around here, and it's got old quarry marked along this area, and quarries along here. So, went along, have a look, and this is what's left of those quarries. So Castle Farm Road's just off to the right there a little bit. When I first did the Ouseburn trips, just did the lower Ouseburn bit, and then I ran a trip where we started off in the Victoria Tunnel, and then we walked up, and then we went up and over the City Stadium, and then we went down past Eden Park and everything, and up through Chesney and stopped at Castle Eden Bridge. And that was it, that was the day. And I didn't know just the other side, 50 yards the other side, Castle Farm Road, and the bridge was this wonderful exposure of sandstone. This is a closer view of it, and closer still. And these are these shale bits and lots of sandstone here. Lots of layers of sandstone. There's a bit of a wavy surface here. This is when you've had a high energy event, a flooding event, a seasonal flood. It's brought down a lot of sediment quite quickly, and it's eroded down into the material below before it's deposited its load of sediment. Further along, just heading closer to the bridge, we then have some shales above these sandstones, and then this undercut area, and then more sandstone above. And if you look closely at the top part of this little black line here, that's coal. So that's a little thin coal seam at the top of that. This material underneath is what we call a seat earth, which is the fossil soil. It's the soil that the plants were growing in. And where the hammer is, hard to pick out, but that line running down there is actually the root. It's a stigmaria, the root of one of the carboniferous trees running down there. Looking back from just, that photo was taken from just around the corner from there, looking back along the cliff face there, the coals in there, the seat earths here, shales down here, and in these shales, if you have a little look around there, you'll find some plant fossils. This picture on the right is called Calamites, which is the relative of horsetails, modern day horsetails, but these were 30, 40 metres tall. These were massive great things. An example from the internet of a bit of a Calamites. You can see the little nodes here, the little lines where the stems would have come out from, and this is from one of those pieces of shale just down from that cliff there, and the nodes are running along here and along there and along there, and the lines running up it. That's much better on there. This is on the screen here. There you go. So you can see, as I say, that's those nodes there, one of those lines there, and one of those lines there is corresponding to that area there. So just a little bit of poking around in the shales there, and you can see a little Indian castle. Now, Calamites there isn't one of the coal plants. We only discovered this relatively recently, I did it half a years and some wonderful pictures. Just think of all of these carboniferous plants and think of them growing as a forest, a lush forest in these swampy, peaty areas. But they don't, they grow, they've got their own different habitats. And the Calamites and things, the horsetails, they like these little areas here. This is the main river channel going up here, and these are the levees that build up on the banks. And one of the main trees that used to grow there is one called Sigillaria, and that's a few Sigillaria trunks in the Hancock Museum, in the sort of carboniferous area. There's about 5 trunks of Sigillaria. Well, they grew on the levee, but over here is where the swamp, the peat swamps are. So this is where your coal would be coming from. So the coal's coming from a group called lepidodendron trees. The horsetails are a different area. So you don't find a mixed range of plant fossils in one bed. You find them restricted to different beds according to which part of this system we were at. So we actually build up the sort of landscape as it was by looking at it. Another thing we get is these mussel bands. Set out the mussel shells in there, different species for different mussel bands, and that's how we can relate one coal seam to another one in a different area. This is a good time to go. I mean, this was after the Beast from the East. This is below the Rendezvous Cafe at Whitley Bay, and after the Beast of the East was there, it swept so much away you can actually see this really clearly. Now, somebody been to Whitley Bay the other day and said that there was a lot of sandstone exposed and everything. You go down and you can see little patches of this still. So we were just there earlier this weekend, and you can see little patches of this. And then the other thing you get is in the coal measures is within the shales you get iron. And this is cheating again. This is actually up at Spittal in Berwick. But all these little lines of orange in the shale here, those are all ironstone nodules. Got bits people can have a look at afterwards. So these are sort of the ironstone nodules. In certain parts of the country, in Reedsdale, these were economic value. They were used as a sort of line. It all comes back to slight little diversion here. This is a website called MinDAP, which has loads of stuff on minerals and mines and all sorts of things. And this is a map of the sort of South Gosforth area with the different coal mines marked on. And that one in red there is South Gosforth colliery, the Gosforth colliery here. Here's the Ouseburn coming down around here. This is a sketch of the colliery, like Thomas Hare, 1840. And there were several around there, but I picked on this one particularly because of the interesting stories. Note some of the reports of the winning of the high main coal, so that's that really important coal that they were working there on the south side of the 90,000 fault. So they were working that. whilst they were working it northwards from the shaft. And then when it reached the dike is a miner's quarryman's term, or was, for any vertical structure. Now we use dike to refer to an igneous intrusion. They used to use it for a fault. So when we say the 90 fathom dike or anything like that, it's actually a 90 fathom fault, it's not an igneous dike. So as they approached the fault, the quality of the coal deteriorated. But they discovered that the other side of the fault, it was much further down. So they actually extended the shaft down huge distance and then worked horizontally through the dike and met up with the coal again on the other side. I think it would be easier to just do another shaft on this. I don't know, they went through. That's that. Mining Institute records, these are great, they're mainly transcribed. There's loads of information on the internet about these. 1,100, 1,200 feet, the difference between the levels. And it was it was the Brandling family that owned the mines there, Brandling pub in South Gloucester. It was such a feat to have reached this coal seam on the other side that they opened up an area, made this huge ballroom area in it, and from, let's say, started assembling at 9:30 in the morning and continued to descend until 1 in the afternoon. When they arrived at the bottom of the shaft, they walked all the way to the coal face. Everybody queued off their own little piece of coal as a souvenir and went back to the ballroom. And when they had enough guests, they commenced dancing and drinking, by the looks of things. Biscuits of all kinds, cold punch, malt liquor. I reckon there were 200 to 300 people down there celebrating the fact that they'd reached this coal on the other side. This is that area again. We've seen this sort of this map before with the 90 fathom fault running through it. Ouseburn up here. And this is the South Gloucester area where those lines were, all the railway lines are going through. And that's our 90 fathom fault again. So they've gone down this side. The high main is this one here. So they were working the high main, and then when they got close to the dike, the coal quality was rubbish. But then, continuing from the same shaft, they went right the way down to here and then across until they hit that one there. And they had to go up an incline because of the way they'd been affected by the faulting and the faulting that distorted the beds. And this is a diagram the drawing has. So this is where they went down through the various different, the high main, the yard, the bension, the low main. I can't read what those two are. Trouble is in different maps, the Morpeth map will name these coals different to the Northumberland, different to the Durham one. So, but some of them be the same names, the high main and the low main refinement. So that's the sequence here. So we have the high main up there, and then we're down through the yard and the bension, and the low main through the cities. Down in the sequence. And if you go on to South Gloucester, Ridgewood Gardens, that's the capping of the shaft. I'm not sure I want my house that close to the shaft. But anyway, and then if anybody knows anything about these, I've done a little bit of looking into it. There are a couple of these marker stones. This is the same stone just from other sides, and they're called the dike stones. And in celebration of their achievement, they put up these stones. And it says on here, the main dike, distance from the pit 349 yards, cut on the 3rd of June in 1828. This one, it just says main dike on the side of it. And then in St Nicholas Church on Church Road, just up from South Gloucester, there's another one. It's lying flat on the ground, it's there. And it's got a crack in it, and it's got main dike written on it. I wanted to see if you could lift it to see what was on the other side, but I have been reliably informed that there's absolutely just plain on the other side, so nothing on it. Intriguing thing is I marked where they were, so that's where the shaft is. This is where that first one with all the writing on it is. That's the one that's on the ground in the churchyard. That's on an old map when the colliery was still in operation. So the shaft was there. That's where that first one. I couldn't find any labelling on any of these old maps that was saying, "Oh, that's a stone or anything on a map to match it up with." So they weren't ever recorded like that. And then I drew a circle around the one that said 349 yards. And they did it at a diameter of 349, radius of 349 yards. And it doesn't go anywhere near where the shaft is. But those buildings, the row of houses where it's next to on from 1828. So have the stones been moved? I would have thought they must have been, or that one certainly. I don't know quite how it fits in relationship to where the actual dike was. Anyway, that's where we're going. Right, back into the Ouseburn. If you work your way down to south of Castle Farm Road, the Dean Bridge, away from the bank, there's a disused quarry in lovely sandstone, Blackberry Crag or Blaeberry Crag sometimes. I've read quite often, if you look this up on the internet, you'll find them saying, oh, it was a millstone quarry. I can't see that. It's rubbish stone from millstone. It's not coarse enough at all. When you hit it, it splits quite easily. It's very fine layers. Much better as a building stone. With all the building going on around there, that would have been much better idea. And then a bit further down, Jesmond Waterfall. The mill's just off to the side here. You've got to be careful when you look at this. So there's a nice outcrops of sandstone there, but this was all landscaped. So if you look at these big blocks up here, you'll see the mortar and the cement between the blocks. So he's managed this, manipulated it to produce that lovely waterfall. The stuff down here is natural, and the stuff down this side is natural, but the stuff around here has all been sort of man-made. Not much further than down there, there's not much you can see. There's a few little exposures, a couple of waterfalls on the street. There's not a great deal more to see when you're going further down, until you get right down towards the mouth of the Ouseburn, where it's all been built on. The Metro Bridge, farm, stables. This side, this is on the west side, and on the west side there's no outcrops of rock at all. It seems to be sort of terraced, and on the geological map that's marked as all shale on that side. But on the other side of the valley it's all sandstone, solid. And if you look at the other bank, this is the other bank, and it's all steep and solid. Lots of buildings on there. I couldn't find any rock apart from, this is from Biker Bridge, and if you look on the sort of eastern edge towards the Tyne, there's a little exposure here. Can't get into it. This was all locked up, and I think we were seeking planning permission to build on it. But that's what you've got there. So that's the only outcrop of sandstone down in the lower Ouseburn. It's quite hard to do a talk on the lower Ouseburn. There's not what to see. But if you go further down, you see the banks of the river, where it's all been channelized. It's all been built up, but in the joints and everything, the drains, there's lots of orange coming out. That's iron. This is iron from the old mine workings. So the iron is out of the shales, and the iron is being washed out into the river. Drift map, this has the superficial stuff, the soils, the glacial deposits, and the made ground. So glacial deposits, boulder clay. This is a map when glaciers were moved. The last glaciers disappeared from here about 17,000 years ago, something like that. And as the glaciers move, as the ice sheets move, they bring rocks with them. They drag rocks with them from where they come from. And when they melt, they deposit those rocks. We call them erratics. And certain rocks, like sharp granite, so easily identifiable. If you see sharp granite erratic, you think, well, the ice must have come from sharp. Well, they could have got here. And by plotting the various different things, you can get a map of where the ice sheets have come from. So we've got Tweed erratics, Criffle erratics, that's sort of Dumfries and Galloway sort of area, Cheviot erratics, and Lake District erratics. And our Ouseburn area is somewhere around about here, bends in the rivers. So we know we've got ice going over here. This is a LiDAR view of the area. LiDAR's laser scanning the Earth's surface, and you can pick up all the lumps and bumps. And you can see there's all these ridges running from west to east. This is the Ouseburn coming down here, that's Gosford Park Lake here. The Ouseburn starts over here, comes along here, then comes down there. You can see there's a big channel up here, north of the Gosford Park. These are all drumlins. These are all features left beneath the ice sheets that go along. So again, it tells us the way the ice was moving. You can see it was coming along and it was sweeping around. There's not much in the way of features in there because the ice, there was so much melting going on underneath it. It deposited clays and sediments that it sort of obscured that. Map showing topography again, and Chesman Dean, Gosford Park, that channel I said you could see on the previous one up here. So these are all meltwater channels. Some of them will be subglacial meltwaters, Prestwick Carr. So all these areas where the cars are in Gosford Lake, they've got muddy lake sediments and clay, and clay's impermeable. So that's why you get the wetland areas there, because the water just can't drain because it's got this layer of clay underneath it. Oh yes, yeah. So the arrow down here, this is from the British Geological Survey. These are all borehole records they've got. So you put them online, different colours regarding to the depth that the boreholes have been done to. And this one down on the bottom right is the St Lawrence Colliery. And the interesting thing with that was, it was first started, I don't know, way back in the 1700s. But again, they were working behind main coal, but they didn't do much working on it before they got flooded, so they had to abandon it. And it wasn't until 100 years later or so when they started working the Friars Goose seam, or Friars Goose colliery on the Gateshead side, and they installed pumping machinery to pump the water out of the mines. They pumped the water out of the mines there, and suddenly found that St Lawrence colliery was drained. So they could then work through it, and work all the way down to the low main. It's got all the thicknesses there, all these different ones that you go through. I like this one mainly because it's from the Natural History Society's transactions, and it just summarises that. It says about the roof workings, and when they worked through the roof, the coal suddenly stopped and they had gravel, not coal anymore, not sandstone, gravel. And then when they worked through the gravel, that's when the water came in. And the pebbles and cobbles and things that came out of this gravel, it says here that they sent the boxes specimens with this letter to the Natural History Society. I'd love to know where that is, if it still exists, because it says here there's no reason to believe that the lower seams are at all affected by the gravel, so we are now processing the lower main seam. But these are glacial pebbles, meltwater pebbles. So again, if you can identify some of the exotic pebbles in there, it can tell you where they come from. And this is a plan that you did at that area. So this is the high main workings here. So they came working in from the shaft and working their way along until they hit this gravel. And then they abandoned it, as I say, it wasn't until they got pumps in these mines here that this all drained. This is the extent of the gravel in the bottom of the Ouseburn. And this is a cross-section working their way through the coal, and then this roof of gravel there. So yeah, so the hard problems there. And this is what things going on there. When the ice started to recede, we had ice sheets from the west, from the Lake District, and throughout south west Scotland. We also had coming down from the Tweed, and the Forth coming down the North Sea. And that was the major ice sheet. And when the ice started to melt, it was the ones from the west that melted first. So what we've got down here is the edge of this Forth Tweed ice sheet coming down the North Sea. And the sheets that were coming from the west were melting, and the water couldn't get out. So you've got these ice-dammed lakes forming behind that main ice sheet. And this one referred to as Glacial Lake Weir. And extension going up here is the bit that's going up the Ouseburn. So it's the bottom of this glacial stuff that's affecting the Ouseburn. And this is just what a meltwater channel looks like, a standard cross-section here, with these sands and gravels and things and clays and things down the side. This is looking from Armstrong Bridge northwards, and if you took the trees away, you'd have a lovely sort of replica about these steep sides and this infill bit at the base there. And we don't really know what it looks like because so much has been infilled. But around about the start of the railways, we built railway bridges, and they were very popular with artists. So artists came along and drew sketches and paintings of the railway bridges, and you can see the shape of the valleys before they did the later work of infilling. I'll stop there now so you've got some time for questions there. Okay.